All right, here is the last group, 16 through 20. Find the value of x that makes those parallel. So I'm looking at these two, and this angle is obtuse. This is obtuse. They are going to equal each other because they are called corresponding angles. So you have 2x squared is got to equal 98. So you're going to divide by 2 on both sides so that you get x squared by itself. That's 49. And if you square root both sides, x could be 7 or -7. -7. So that's what 7 squared is 49, but also -7 squared is a positive 49. Sorry, 49. So yeah, 7 and -7 would be your two answers for that one. 7 and -7. So let's put those in. 7 and -7. All right, 17. Oops, went too far there. My bad. Always does that for some reason. Okay, 17. Why is it doing that? Okay, sorry guys. Keep skipping all over the place. Okay, 16 we just did. 17. Find the slope of each side of the quadrilateral, then determine if it is a parallelogram. Well, parallelogram is exactly what it sounds like, parallel sides. So let's see, we're going to go up. From this point, we go up 1 and over 1, 2, 3, 4, 5. So up 1 over 5. Let me change that to a different color because these are already blue, so that's probably not the greatest color to use. Let's go red. Okay, so up 1 over 5. And this one goes up 1 and 1, 2, 3, 4, 5. So those are so far parallel. This one is parallel to this one. Both of those have a slope up 1 and over 5. This one is down 1, 2, 3, 4 and over 1. Down 4 over 1. This one goes 1, 2, 3, 4 down and over 1. -4 and a 1. So yes, that is parallel. -4 over 1. And so you could also say that this line is parallel to this blue line. 2 arrows goes to 2 arrows. So yes, that is definitely a parallelogram. So AB and DC have the same slope, or CD, and then AB and AD and BC have the same slope. AB and CD have the same slope. So this slope, AB, was 1/5. Okay, that was A to B. Sorry, A to B was -4. My bad. That was a -4 over 1, which is just -4 slope. BC was the 1/5. Okay, so BC, nope, I'm sorry, that wasn't E. Oh yeah, it was the 1/5. CD is also -4. And AD is also 1/5. Okay, so that means the definitely parallelogram because you got two pairs parallel. So quadrilateral is a parallelogram. Definitely a parallelogram. All right, that was, I knew that was going to happen. Shoot, sorry. Why it does that. Okay, trying to be nice and gentle with it, and it keeps going down like that. All right, there's 17. Now let's go to 18. Okay, you're riding your bike up Elm towards Deer. You plan to make a left on Deer Trail. Okay, so let's look at it and see. We're going up Elm Street towards Deer Trail. You're going to plan on making a left on Deer Trail. Okay, so what angle did you turn? So this angle, 68, because 68 is acute, so it has to be an acute angle. But this is obtuse. So I just got to take 180 and subtract 68 from it because the two of them have to add up to 180. If they're parallel lines, they got to make 180. So we're going to subtract here, and you're going to get a 112 degree angle. 112 degrees. So 112. Okay, there's 19 coming up. Don't go down, just please. Just go up gently. There you go. Okay, 19, no lines are, but let's see what we got. Oh, we got some, which statements have to be true? Okay, let me just go up a little bit more. All right, there it is. So let's see. What has to be true here? Let's see. We have perpendicular lines here. So let me go back to blue here. So you see this perpendicular and this perpendicular. Both these two lines right here, A and B, are both perpendicular to E. So A and B have to be parallel. So that has to happen. Okay, we also see that E and D are, so that means that A, B are parallel. Okay, let's do that. So we also see that D and E are both perpendicular to line B, so they have to also be parallel to each other. So two arrows, so that means D and E have to be parallel. D and E. And let's see, anything else have to happen? Let's see, if A is parallel to B, we know those two are parallel, we know D and E are perpendicular. C, it doesn't say, we don't have enough information about C. We don't know if they're perpendicular, so we can only say those two. So AB and DE. So I like AB and I like DE. And last one, number 20. You're setting up a zip line in your yard. I guess that's as far as it goes. Okay. You're setting up a zip line in your yard, and you map out your yard on a coordinate plane. An equation of the line representing the zip line is y equals 2x plus 4. There is a tree in the yard at negative 411. Each unit in the coordinate plane is 1 foot. How far away is the tree from the zip line? All right, so let's draw a quick graph here. So 2x plus 4. So we're going to go up 2 and over 1, up 2, over 1, and that is the equation. I wish I could draw a straight line. Maybe I can. Maybe it will let me draw a straight line here. Okay, so let's get rid of that now. Just touch it again, it goes away. Okay, and then we've got negative 411. So let's see, 1, 2, 3, 4. That's way up here. Negative 411. So what we need is to find out how far the tree is from the zip line. What we need is a perpendicular distance. Remember, I told you we need a perpendicular. So we need the slope. We need a perpendicular slope to equal negative 1/2. Negative 1/2. And we need this to be my x1 and my y1. If I want an equation, I don't need an equation. So I just need the new slope. Okay, so let's just do this slope. Let's go down 1 and let's go to the right 2. So down 1 and over 2. Down 1 and over 2. That would put me on here. Down 1 and over 2 is going to put me there. So we just need the distance. Our a squared plus our b squared equals c squared. So we went down 1 over 2, down 1 over 2, down. So we went down 3. And we could look at the coordinates. We know this coordinate is negative 4, 11. And then this point right here was over 2 and up 8. So yeah, from 11 you went down to 8. That was a minus 3. So that's this one right here. From negative 4 you went over to positive 2. That's a 6. So it's a 3 squared plus a 6 squared. It's 9 plus 36, which is 45. And we're going to square root that. So let's see. We've got the square root of 45. Okay, so square root of 45 is 6.7. So C is approximately 6.7. Round to the nearest tenth. So we're going to leave it as 6.7. That's this distance right here. I got that by using a perpendicular slope. You have to use a perpendicular slope. Graph paper is nice for that one. If you have graph paper, that would be easy, or better. I'll try to leave some graph paper for the sub. All right, there you guys go. Good luck.